Okay, well, welcome to Scicloj, a Clojure community that discusses science, data science, machine learning, tools and techniques. My name is John Stevenson, author of the Practically series of books. I'm currently running a study group on YouTube. I'll be your moderator for the meeting and try and make things run as smoothly as possible, internet providing. We've had three really interesting talks so far. We've had a really interesting talk about the next journal by Martin Kavlar, Emacs Net for deep learning with Karen Meyer, and Tech.ml from Chris Nuernberger. Hopefully I've said that correctly this time. And all these videos are available online on YouTube, and this one will be available in the next within the next few days, if not sooner. So we've got two really excellent discussions for you today, and I hope you're going to enjoy them. I hope you're going to take part and ask lots of questions as we go along. So Chris Nuernberger is back again, this time talking about Libpython and using Python from Clojure. And although there's been a big increase in adoption in data science, using Clojure in data science, there's a large body of Clojure code and libraries out there that we can tap into when we just want to get things done. There's no sense in kind of reinventing the wheel all the time. And so Chris is going to show us, by using some 2D plotting libraries called Matplots, how to use Libpython-clj, and gives an example of what's involved in using that library. And there's also kind of like a next journal example that we've already given you as like an example that you can go away and play with as well, which is it's a really nice platform to help you kind of share examples and demos without having to worry about people's dependencies getting them right. And the second talk we're going to have is Alan Marazzi. Marazzi. I need to practice my Italiano. It's terrible. Sorry if I've caused anybody any offense in that terrible rendition of Italian. So Alan is going to talk about Pandas, which is not the cuddly animal. It is the Python data analysis library. And so again, we're going to be using that from Libpython-clj, and also going to be playing with Numpy as well, which is a well-known library in Python as well. And you're going to be using like the classic Jupyter notebook to demonstrate that as well. And at the end of the day, at the end of the meeting, we'll still have plenty of time. So there's lots of kind of time for discussions, and we'll talk about kind of the challenges around community, what we want to do with the community, and how we can keep on building that as well. So we really appreciate your input on that as well. So thanks very much for joining us, and I hope you'll take a very active part in this meeting today. We want you to, if people have webcams and they're not too shy to share, that would be great. The speakers do appreciate having somebody to look at while they're talking. So if you do have webcam, please do share it if you feel comfortable doing so. And both speakers want to kind of have as very interactive as possible this session as well. So please ask lots of questions. We're happy to for you to ask questions over the video chat, over your webcam, or you can ask questions in the chat as well. I'll be monitoring the chat to see to ask those questions as well and make sure the speakers see those. If you are going to ask a question, then please kind of mute your microphone afterwards as well, so we're kind of minimizing any background noise as well. So without further ado, unless there are any burning questions before we start, I'm going to hand over to Chris, and he's going to teach us all about Libpython and using Python from Clojure. If he's still here, is Chris?
Absolutely.
Oh, there we go. There we go.
There you are. So I'm going to try to share my browser. So first we're going to go here. Can everybody see? Man, this is, here we go. And here we go. Come on. Isn't. Oh, it's not going to, there it goes. Okay. So can everybody see my slides?
Yes. Yes.
Okay. So I mentioned in the initial discussion that Alan gave me the idea for doing this by pointing out that there is a library for NLP he wanted to get into called Spacey. And Spacey, the C++ bindings for Spacey were just built directly on top of Libpython. And I decided to research how hard it would be to bind the JVM to Libpython, and in the exact same way, and thus get access to every single Python library that was pretty much ever written. And so I want to highlight my motivations for these are that, in my experience, Python is becoming the way that people are actually publishing a lot of research. So they'll do a lot of research in C++, but usually when they're done, they'll use Boost C++ and put a little wrapper on top of it so you can use their research easily for Python. That means that we're not getting clean C interfaces. So the repercussion of Boost Python is that it's not like they're taking their library, producing a really nice C interface on top of it, and then putting Python on that C interface. They're pretty much taking their library and binding it directly to Python itself. My experience from using Python is that it's fun. I like the simplicity of the language for sure, but the REPL experience leaves me a little bit frustrated often. And just, I don't feel there's any REPL experience as good as Clojure. And that's true whether you're using Clojure from Emacs or Clojure from IntelliJ, or I really don't care how you're using it. Clojure's got a really good REPL experience. That was a key part of the design. Schools like Galvanize, and there's a Galvanize office just a couple miles from my house. There's a Galvanize school just a couple miles from my house. They're just pumping out lots and lots of people who know a little bit of Python and kind of a lot of data science, or a little bit of R and a lot of data science, but they really don't know a lot of other languages. So from my perspective, in order to work with a lot of these people efficiently in the short run, using the things that they produce is important, and it's way more important than asking them to start learning Clojure, or reproduce what they did in another form. And then, so this last point is, I know, going to be controversial, but it does reflect my feeling on the matter, in that with containerization, pure Java is irrelevant. The pure Java kind of, we're going to rebuild everything in Java because then it's pure Java, is oftentimes acting more as an anchor than an advantage. You don't get that much, in my job at least, I haven't gotten that much out of things being pure Java, but I've certainly seen a lot of resources being built to rebuild tools in pure Java that potentially, that wasn't a necessary use of resources. So my goals are, overall, to make using Python from Clojure really, really enjoyable. I want it to feel like you're calling Clojure code when you're calling Python code. And you really shouldn't notice a difference between using Python and Clojure, especially if somebody takes the time to wrap the Python libraries with the library. I want to know absolutely that Clojure has access to the latest research. That is key for a lot of the things that I do. I want to see how the latest research performs against more standard things, and especially in facial rec or in image processing in general, or even in NLP, things are coming out in Python before they're coming out with Java bindings. For the long run, I'd like to provide a gradual pathway. So if you spent a lot of time in Python and you are really good at using Numpy and Pandas and the massive set of tools that are available in Python, I want you to feel like you can use Clojure, but you're not walking away from years you've invested learning these tools. These tools are difficult to learn. They have a lot of ins and outs, for better or for worse, and they have a whole lot of power. So even if there's some equivalency on the JVM, if I'm a really good Python programmer and I want to learn Clojure, I shouldn't have to pay a massive tax to relearn everything that I know. And so going down that path a little more, I think Clojure and Python are actually really, really, really good complementary languages. They are both typeless, and they both focus a lot of times on getting things done, really pragmatically just getting it done. You can get an enormous amount of things done in both languages. And unlike say, Groovy or Ruby, Clojure and Python are very different in some fundamental aspects, and they're different enough to be complementary. So using them both, you cover a wider spread of the languages that people like to use, and that spread is important because each point in that spread has a real, reason for being there. So it didn't take much supporting infrastructure to build to build the language bindings, and I say this because there's other languages like CPython that we might want to bind to. I'm not going to go over these libraries. I already have in other talks, but basically it took these 3 libraries, and that was it, period. And so real fast, before I get into actually demos, I want to talk about, in my opinion, what makes a good language binding is that we can exploit Dave's type symmetry. So if I'm using a dict in Python, I should be able to use it like a persistent map in Clojure, assuming I'm doing read-only access. Or at the very least, as you'll see later, if you have these Python objects, I bridge them into the JVM by deriving from the correct container classes. And that gives me just basically this list of things: maps, lists, dicts, tuples, number, strings. With that much done, I can actually communicate with a huge number of things without needing to rewrite a whole lot of code, or without needing you seeing the bridging explicitly very much.
Chris, sorry to interrupt. I think we're just seeing the your slides in the without the presentation.
Oh,
yeah,
really?
So we're not seeing you moving on the slides, so we're only seeing we're not seeing the presentation view of it.
Oh, that's frustrating. Okay, give me a second.
Sorry about that.
No, that's useful to know. I guess that's why it was so confusing when I was trying to share.
Yeah.
I will know in future.
Oh, there we go. Oh, that looks good.
So I will share these slides later. I'm not going to go back over the things I already said, but that's unfortunate.
Yeah, that's fine. Yeah.
So good language bindings. The next choice, so data type symmetries is the most important thing. In this way, I can transform data between the languages without you seeing a whole lot of engineering. Explicit choice between copy and bridge. This is really, really important for performance. I haven't fleshed out the deep copy or the shallow copy pathway because it's more error prone than the deep copy pathway between the JVM and Python. But in general, if you're going to hand me a language binding and ask me if it's good or not, I want to be able to control when it copies or when it bridges specifically. And you'll see what I mean by that later. It needs to have great REPL support. I went through some amount of effort to make sure that when you print a Python object, its toString method is actually called in the Clojure REPL, because a lot of Python libraries actually have fantastic support for printing, mainly Pandas and Numpy. You can print out really large Numpy objects, and they actually have reasonable definitions in text. It doesn't just dump every number to the screen in a naive way. Allow each language to be each language. So I'm not trying to make Python Clojure. I'm not trying to make Clojure Python. And if you are writing a Clojure binding on top of a Python library, I don't want to get in your way with my layer that's trying to just provide you the ability to do so in the first place. And then the last point is really important, I feel, is zero copy pathways for dense buffers. And so that means that I can actually get a pointer, a long integer, and a data type, and both languages, given that definition, potentially a shape as well, but that definition alone can do something on the same buffer. And so that obviously gets into mutation, and it gets into when do you copy versus when do you actually share. But for things like a stream of images or video, there might be a really good reason I don't want to copy into the other language. So I don't want to be forced to all the time. I want there to be a zero copy pathway. So both languages can just sit on the underlying native structures. And so this gets me to my last slide really at this point. And that just thinking of it in your head before I jump into it, what if you could use Python libraries as easily as you use Clojure libraries? What if it was just a matter of, Keras or TensorFlow or who knows what? It was just a matter of import the Python library and it hands you back a thing and you can use it. That's one aspect I want you to think of, because that's the bridge I'm trying to break that barrier. And the other thing I think is kind of important is that from Python, what if you can use JVM objects? So if I'm in a Spark cluster or something like that, can I just hand some JVM objects into Python code and have Python treat them like a Python dict or a list or whatever, and have Python call them just as easily as it calls lots of other things? So in this way, I can start to extend Python from Clojure the other direction, which is also interesting to do. So here we go. And so I'm going to try to avoid making the exact same mistake twice. Give me 1 second. I have a REPL fired up, and I'm going to share that when I get through, when I figure out how to use the Zoom interface a little better.
The joys of Zoom. Yes, it's tricky on other things as well.
Yeah, it's pretty confusing.
It's probably just easier to stop sharing and then restart the sharing another time.
Yes. Yeah, you're right. That's the best way to do it. Thank you. Okay, so here we have Emacs, and people have asked me kind of what does it look like when I program at a REPL before, oddly enough, and I'm probably one of the most old school people in REPL land in that I just use Emacs. And I don't even use all the toys for Emacs oftentimes. I don't really get into that much. I just use Emacs. And so to save a little bit of time, I already booted up this REPL. And this is one of the examples that that come with Libpython. Basically, I fire up the REPL, and you'll see a few of these logging statements print out where it actually finds Python 3.6, and it starts the reference thread, because one thing that Libpython takes care of for you that you may not realize, and hopefully never have to realize, is that I bind the Python objects to the JVM's garbage collector. So when you create a bunch of Python objects, the deref calls for all those are bound into the garbage collector, such that when your Java code no longer is referencing those Python objects, another thread will dereference those objects, telling the Python runtime that you're no longer referencing them. And that's an important part, I think, of bridging things. Or you only can copy. You cannot bridge at that point if you cannot do that. So let's create a Python dict. So what is that? If everybody, I don't know if you can see or not, but I hit Control CE, and that just runs the code that is next to the cursor. And we looked at that. So this is in copying. This is basically a Python object that is a raw pointer. And I will get further than that, but there's a Python library, gives you a couple methods that you can do something with it. One of the most interesting methods, I think, is the @type map. This is really key. And this kind of also proves that I'm actually running Python, in my opinion. Maybe you don't believe me. But this is actually all the attributes on a dict. And to take a quick, brief digression into how Python actually works, it's basically a system of maps. And your map interface of get item or get something from the map, or set something from the map, it's a map of attributes. So you can get an attribute or set an attribute. And attributes are whatever you call through the dot operator. And this lists all the attributes on the object. And I'm not going to say too much more. You'll see a lot more examples of how to use it later. But this is really, really helpful. This is the one thing you always need in Python, because a lot of times you get a random object back and you don't really know what it's got and what it does or anything. You can always just list all the attributes and their types, and that at least gives you some level of a map. So the Python library generally works in bridged mode. And what bridged mode is I wrap that pointer with an object. So if I look at the bridged object, that bridged object, that was actually the Python's toString attribute that was called. So call attr bridged stir. It returned the same string that your REPL printed out. So I override the toString function. I'm trying to take care of people in the REPLs, because one goal would be if I can make a REPL of Python as nice as a REPL of Clojure. And the easiest way to do that is to make the Clojure REPL interact with the Python runtime in a slightly deeper way. But anyway, the bridged object, this is one of my points, is an instance of java.util.map. And so that means that it is actually going to interact with your Java system and your Clojure system like other Java things. So I can get, and there's no keywords in Python, so things that were keywords end up strings. I can say count, bridged. I can do a fancy double arrow transformation and get a persistent map back. So basically, you're seeing I can use these Python objects like their Clojure objects, and that was a lot of it that I wanted to show. So we're going to do something really quick. So I can import modules. On the left here, I hit Control-CE, and I'm actually importing the Numpy module. And if we look, it's got a whole lot of stuff. Numpy is an insanely dense library in terms of functionality. There's just not many things like Numpy. It's in the middle between like a pure math library and this pragmatic agglomeration of everything scientists have needed to do in the last 30 years or something like that. It's really intense. You can look up documentation on things. That was the documentation on the linspace method. And so we're going to call, here's some examples of calling the linspace method, and I want to highlight exactly this example. So from the actual Python documentation, we have that. That's going to fail because I just printed out that. And we're going to actually call that method just like they said, using keyword arguments, using all the toys that we have in Python, and that just called the linspace method and gave us back an actual NumPy array. And so I want to highlight real quick that right there is pretty much full support for Python. If you can call attributes and you can call them with keywords and normal arguments, then you pretty much support all of Python. You may need to wrap things in a clever way, you may not to, but you support a lot at that point. So if we look at the NumPy array, we have, actual values in there that are pretty interesting. I can bridge a NumPy array when it comes back into Clojure. I bridge into one of our tech tensors. So that's a key thing because a tech tensor, of course, doesn't support nearly what NumPy does. I don't want to bridge NumPy objects until I have a reason to, but once I bridge a NumPy object, the tensor and the NumPy object are sharing right to the same memory. So I can essentially, I can basically set values on it, and I want to just show this in the actual REPL. So I set the value on the tensor, and so I set position 2 to 6677, and you can see it printed out a new tensor. Well, it printed out the same tensor actually. Set this is a bang method, so it just wrote to the tensor. And if we look back at the array that we got back from linspace, it's showing that I changed the array under the covers. So not to try to make myself the least popular person in Clojure, but there are times when you do need mutability. And dealing with really large, dense numeric buffers is often one of those times. And actually, that's probably the only time, really. But you always have the option to copy the tensor, and there's optimized methods. I put a lot of energy into optimized copy of, for instance, that native buffer into the JVM, into an actual JVM array. There's lots of things you could do. So if we create a float array of 5 depth, so we have a test array, we could just do tens, test array, and then we have this. Now that actually hit an optimized method because the JNA system optimized that. You can get the data back into the JVM. That is an actual float array. So I don't know how to show that any other way, but like that is a JVM array. You could pass this into one of the Java matrix libraries. You could pass it into Incanter. You could pass it into Kixie.stats. You can do whatever you want. So you can get the data out. You get it in the format you want. If you want to do a copy, whatever. That was pretty much what I wanted to show here. Moving on, potentially quick. we're going to look at matplotlib. So matplotlib is a very, very similar to NumPy. It's something people have worked on for the last 10 years, and it's a very full-featured plotting backend. And this is actually the demo that I have on Nextjournal. So you can take this exact code, not this exact code, but pretty close to this code, and you can remix the Nextjournal entry, and you can start playing with it and plot different things and see what happens. But I'm not going to actually show this very well because I can't easily show the result images due to sharing. Okay, well, then let's actually pop to the Nextjournal entry real quick. And give me 1 second to hit Nextjournal. And I will now stop this. And so let's hit the Nextjournal entry. So now I'm sharing my Nextjournal entry. So this is now a static journal. I could edit this or remix it, but I think I'd rather move on to Alan before I go that far. But basically, I show the same tricks in that I show you how to use NumPy. We use matplotlib to plot some stuff, and I plot it to a CPU-backed canvas. So I'm not plotting it to a GTK canvas or some windowing canvas. I'm plotting to a rectangle of memory, and via NumPy, I bridge that rectangle of memory directly into Java. And I show basically how you can get values from that buffer after, so you could get the data out and do something else with it. And I basically show various different things that happen when you copy it. So that's the next journal entry, is showing a more in-depth integration where, for instance, the data types library of unsigned bytes is really important because everybody who writes images writes them in unsigned bytes. So having libraries that don't know how to manipulate unsigned data drastically limits you dealing with the rest of the world. And I basically show how to rearrange data and that kind of thing. So I know that was a whirlwind. I hope I wasn't talking way, way too fast for everybody. And I would like to finish up a little bit of my slides. I think I'll just finish on the slides and then we will end there. So let's see if my, new share button, nice. And so here we're back to demo. That was my hopefully not too fast demo, but I'm sure that was pretty fast for most people. So where do we land? I just showed you could load Python. You can call Python libraries like their Clojure libraries, more or less. A lot of best-in-class libraries are available to Clojure now. So one of my goals 3 years ago was to make sure Clojure had access to the best libraries to do anything that we wanted. And this actually satisfies a significant portion of that goal. Libpython-clj isn't finished. That will take more work. That'll take help. If nobody helps me, then Libpython-clj is actually finished enough that I can use it professionally, and I already have. If we want to have a really nice place for Python people to live, we should work on Libpython-clj and make the REPL experience really good. There's lots of space to fill because there's a million Python libraries, knowing which are the best ones, knowing which ones are worth actually binding to, and actually building bindings to them so we can interact with them like we do with any other Clojure library. There's a lot of work that could be done there if nothing else happened to Libpython-clj. So the last point, I think, is, it works. We can call TensorFlow, we could call Keras, we could call Emacs, we could do anything in Python that the Python people can do pretty much. And the price for this overall is that you're going to have to use containers. Because to take any of this to production, you're going to need containers for it to work. If you were using Python, you already had to use containers, is my guess. And so that's it. It's just not pure Java. And with that, it's my thank you slide. And I would like to give up control back to the moderator. And that's my talk.
Thank you very much. Thank you, Chris. That was excellent. I learned a huge amount there. Very insightful. Does anybody have any kind of questions just before we move on to Alan? I thought that was it was great. It was great to see that you could use this stuff for real. So you're actually using this in production yourself, is that right, Chris?
I'm not using it in production. I am using it in order to. I inherited a large amount of weather modeling code.
Right.
That is all written in dense numeric Python, and atmospheric modeling and nuclear physics are things that we still need supercomputers to do.
Right. Yeah.
So in order to pull out the pieces of this weather modeling code and to test them and to figure out what actually works and what doesn't, I've been using this Python binding.
Okay. Okay. Yeah. So to help you understand what to do with this thing when it does go into production.
Yep.
Okay. Yeah. Great stuff. But for other projects, would you feel comfortable using it in production? Do you think it's good enough for especially like smaller projects? Obviously not the ones you. Yeah. For
smaller projects, I think it's good enough. For larger projects, I think we need to work hard and make really, really sure that the two GCs are actually working together really well.
Right. Okay.
That's just a little bit of careful stuff, because I could see there being a memory leak in somewhere. I could see a lot of things happening if you try to really do it big. But quite honestly, when people run Python in production, most of them are not expecting that Python program to run long, because they've had memory leaks.
Yeah. Cool. Okay. That sounds great. And so, we shared the repos for that as well. So that's fantastic. Any final questions before we move on to Alan?
Yes, I have one question. Hi, my name is Juan. I'm seeing in the documentation that you need Python 3.6. It works also with Python 3.7, the last version also?
Yes, absolutely. There's a dynamic variable that you can change before you call initialize, and that'll cause it to look for a different library.
Okay, thanks.
Great question as well. Thank you very much. And
uh-oh. Man, I just lost John. Did I lose everybody?
No, I see you, Chris.
Okay.
Yeah, John phased out.
Well, as long as we don't lose Daniel, we have the recording. So the most important thing, maybe, is Alan still there?
Yeah, his image looks frozen on mine.
Man, I don't see Alan's video either.
Huh. Maybe there's a... you and I are the only ones in the U.S. right now, so maybe that's what the difference is.
Right.
Oh,
that's a huge bummer. Oh, Alan can see me.
John's back now. Yeah, I see. They're moving now.
Okay.
Can you hear me?
Yep.
Yes, I think we can hear you, Alan.
Okay, great.
Great. Yeah. So before anything else breaks, over to Alan.
Okay, great. Hello, everyone. I'll just try to share everything at once. Let's see if it works. Okay. Can you see now Zulip?
Yes, and now your presentation.
Okay. Great. So, I started to develop Panthera, and what it is, Panthera, it's a wrapper around Pandas and Numpy, and to follow this talk is better to actually, well, to know Clojure, of course. Then it would be very nice if you know some Python and some Pandas and Numpy, but we can deal if you don't know much about them, because you don't have actually to know Pandas and Numpy internals, so we can deal with that later on. I'd really like this to be as interactive as possible, so if you'd like to ask anything, and I mean it, really anything, there are no dumb questions, only dumb answers, but that would be on me, so don't be afraid and just ask everything you want. So why Panthera? Well, actually, because we can. In my opinion, that's already a nice thing to have. And it's nice because we can fill a blank in the Clojure toolset, because there's nothing like it. as Chris was saying earlier, even just Numpy is way, way larger than anything else we have in Clojure. And I'm talking about raw functionality here. I'm not talking about performance or API or this kind of things. It's just what there is in there. It's just so much, okay? And then it's an access point to a whole ecosystem of libraries. I can show you, for instance, GeoPandas. What is GeoPandas? Well, you can use the Pandas API to deal with geographic data, and it's there. If you already have Pandas on your hand and Python, and from Clojure, you can do things like this pretty easily because you have polygons, shapes, you just basically plot them, and that's what happens. And it's not just for plotting, of course, it's also for doing pretty much advanced stuff. Then I'd like to test this. I didn't have the time. It would be great to see if this works, because what Modin does is you just import it like this, then you use Pandas as you would use it as usual, and this happens. What can be parallelized, it will be parallelized. So if it works, I don't know, it should be tested. That would be really nice to have. Then of course it's nice because we can reduce friction between doing data science stuff, and maybe that happens in Python or in another language, let's say R, and then doing, I don't know, maybe ETL stuff or even just business logic stuff on the Clojure or on the JVM side. What it is, it's a reasoned Pandas wrapper, and it's reasoned because actually the Numpy wrapper, it's not, because Numpy, it's not a wrapper, it's a single access interface, because it's completely generated at runtime. I didn't wrap anything, but we'll see what I mean by this later on. It's a way to deal with rectangular data and vectors. And that's nice because in Clojure, it's not so easy to deal with that kind of things. You can do something, but as I said earlier, there's so much functionality in here, and it's there for us to just take it. And then it could be a foundational block for other libraries. I mean, both on the Python side and on the Clojure side of things. So you can build up things on the Clojure side on this. Because we actually, thanks to Chris's work, we don't lose much of Clojure functionality when we deal with Python. And then this is also a stub for a general Python packages wrapper, because if I have time and I find a nice way to deal with submodules and classes, you can generate wrappers and at runtime for any Python libraries with this. What it isn't, and what it probably never will be, I will never deal with machine learning, at least not inside Panthera, because there are very nice machine learning libraries, but Pandas and Numpy are already so large by themselves that there's a lot of work ahead to do just on those libraries. It isn't a substitute for regular Clojure data transformations. So for instance, if you have unstructured data, then you're probably much better off using Clojure than using Panthera. It isn't a way to push mutability into the language, because I tried to keep things as immutable as possible, and actually Numpy and Pandas are helpful in that regard, because in the last few releases, they made everything as immutable as possible, and in Pandas 1.0, they will completely and totally deprecate the ability to make in-place transformations. And of course, this isn't a way to dilute the Clojure way. I mean, you can always write Clojure code, and we'll see that we can do some pretty neat stuff within Clojure and calling Python code. So how does this work? Basically, this is the Pandas wrapper. 80% of the Pandas wrapper is in here, because what we do in here and with this function and this other function actually is that we take a map, and we convert that map to Python data, or actually to a representation that Python likes for function arguments. And this actually is just sugar over Libpython-clj to not write these things all over the code again and again. So what we can do now is we can define a data frame in here by using this thing. This is the Pandas module. It's imported in Clojure. This is the data frame class. Then we pass in the data and then attributes. When you see attributes, it means that there are many options that can be passed in. And Pandas has, so many options that it's basically impossible to remind all of them, even for just a few methods. This is another way how to use a simple keyword call. It's the same thing over again, just that this time we're not using a module, we're using an object to call a method on that object. But as Chris has shown you before, actually classes in Python are basically namespaces. So you have a map of names. In Python is a dict, but it's the same thing. And you can, even if you don't instance that class, you'll be able to see all of the methods and attributes of that class. So that's pretty nice to know. And this is some other thing I do when I have to actually do many things that are very similar. And this is a nice idea. This is by Chris as well, because it means that the add function, it works more or less as the Clojure plus function. These are dunder methods in Python. These are needed to let Python know how to add things together. Because if you build a new class and it's a point, maybe you want to add points together, and that makes sense in the end. But then, of course, Python doesn't know how to do that. So you have to tell Python how to add points together by using this method. Now, this is much more dense, and this is how I brought the Numpy, but I think it's pretty nice to see, because this here is basically it, and with this you can wrap almost whatever you want, because what I do is get a set of attributes in here. A set, it's really a set of keywords, and these are things I'd like to get out of a Python module or out of a Python class. And then the module itself, in this case it's Numpy. Then I get out from the add type map the vals, so the keywords I want. Then it's just some sugar to deal with things. And then there's this function that takes a keyword and then returns a function that, if called without arguments, just returns that attribute from that module. This means that we're returning the raw Python function, because everything in Python is an object. You can pass function around because they are first class. So we can actually pass Python functions around from Clojure. And I think that's pretty cool to do. While if you just pass attributes, of course, you're going to call that function with those attributes. Then I say this thing, it's, I build a map that says this thing is a function, it has a doc. I take the Python doc string. So if you just say in the attributes, when you call the function in here, doc true, you're going to see the original doc string, because of course this is it. There's nothing else, so I won't be able to put doc strings anywhere. You have to use the Python ones. And then, of course, we pass the original function in here, and then just build a huge map of all the functions. Then we have this as an interface to access all those functions. If we call just mpy without any argument, we can see all the keys that are in there that we can use, so all the functions and or attributes. If we pass a key, then we get the raw Python function and nothing else. If we pass a key with arguments, then we're calling the function with those arguments. I had to deal with a lot of trade-offs. The first one is consistency versus accuracy. And what I mean here, I'm not going to show you lookup and drop right now, but Pandas has a lot of inconsistencies. If you start wandering around the documentation, you'll find a lot of them. But then being accurate in replicating the API on the Clojure side, it's nice because you can look at Python code and just mostly replicate it on the Clojure side. So this is the first trade-off. And actually, I moved a little bit more toward consistency than accuracy. Then there is parallelization versus functionality. I mean, Pandas and Numpy have a lot of functionality, but of course in Clojure it's much easier to parallelize stuff. And at this moment, I'd like to get much more functionality and not focus too much on these things. As I was saying earlier, there's modding, but we have to try that. Then laziness versus ease. Of course, we can do everything pretty much lazy because in Python you have generators. They're pretty weird to write, but you can do that. But then everything will be much more difficult to grasp. So at this moment, everything is just on the easiness side. And then, of course, the greatest trade-offs of them all, which is Python versus Clojure. And here I'm just going to say that at this moment, the best thing to do is to keep the Clojure stuff on the Clojure side and the Python stuff on the Python side. We can mix match things, sorry, a bit, but at this moment, I wouldn't do much more than that. Now we're moving to a little demo. So can you see the notebook?
Yes.
Okay, great. I already prepare settings in here. I'm getting just Panthera. As you can see, this is in alpha. I'm hoping to release the first non-alpha version in the next few weeks. Alpha here means that everything can break at any time, okay? Just to be clear about that. This is just a nice helper that calls the toHTML method of an object, and we'll see what happens. Then we can read this nice CSV and tell Pandas that we will like the option to read only the first 10 rows out of that CSV. And as we can see, we get only the first 10 rows, and show does just this. In the notebook, we get the HTML representation instead of the string one. But it's the same data, of course. But just to show that there are many ways to do the same thing over and over, again in Panthera. Now we're at the CSV, and we said we want the head. We want to see only the first 10 rows after reading the whole CSV and then show it. And this is the same result as before. Then we save, of course, the data into a var, and let's move on to some more interesting things. So we can see names. These are the columns. As you can see, this is an index, but if we do vec of the index, we can actually deal with this on the Clojure side. Then there's the function shape that says that we have 800 rows and 12 columns. And the nice thing is that this can be used as a Clojure data structure. We get only the rows in this way, okay? Then subset calls. If we put in here just one of the names of the columns, and this works the same if you give strings or keywords, be just aware that there's a transformation going on between keywords and strings. And it's weird because in Pandas you can have spaces in names, so maybe using strings, especially at the beginning, is the best thing to do. This is a series. Every column in Pandas and in data frames is a series, which is basically a vector with a lot of metadata attached to it, because it's indexed, has a name, of course there's a length, and there's a D type. Everything has to be one D type into a series, okay? Then we can say I also want to see HP and defense, and we'll get the data frame out of this. Then another thing we can do, this is how we use Numpy from Panthera. So what we did is call numpy log keyword, which means call the log function. We have taken the speed column. So what this means is that we just call the log function on the whole column. Everything is vectorized in NumPy, so it's also pretty fast to do. And most of the time, if you can find something in Panthera, because I haven't implemented it yet, you can choose. You can either implement it, it's very easy to do, and I accept pull requests, everything, issues, for real, anything. Or it's really likely that NumPy actually has a function that can do that, and you can use NumPy without any problem, because data frames under the hood are just NumPy arrays. Then, of course, we can transform data to CLJ with this function. And this is, of course, a Clojure vector of maps, and it does what you expect it to do. So that's it. These are columns, and this is the data attached. How we build data frames from scratch? We pass a vector of maps, of course, and we get a nice data frame. Then filtering. Filtering, it's not that great right now. I can see. I'll see if I can make it better. But there are many ways to filter data. In here, we're passing a function that takes a data frame or a column or whatever. Then it just subset the columns, takes defense, and then this is a math function, one of those we saw earlier, and says, is it greater than 200? And it will answer, it's vectorized, so it will answer for every value. Let's see if that's true. This is what happens. Is this series greater than 1? What does it mean? Of course, it means that it checks that every value is greater than 1 or not. So if we do this, we just get these rows out. Then, of course, we can do basically what we want with this, because we could define a Clojure function that takes a column, 2 columns, and calls the NumPy logical AND function with as arguments these 2 basically series. Okay. And what happens is that we have now combined two filters into one, and we get a nice result right here. Of course, we have many statistical functions. I mean, many of them, because we have, these are just some of them. And as you can see, I'm calling them with juxt, so we can combine things in a Clojure way, and this is pretty cool. There are many options for these functions. Here, what we got is the mean of every column, but then we can pass actually an axis option in there and get the result by row instead of by column. We can tell Panthera in this case that we would like to not skip an A's, for instance. And this is what we do in here. So what we get if we do a mean of a series with a nil in it, of course, the result is not a number, because not a numbers propagate. Now, something that is a little bit more complicated, but I think it's interesting to see, because here we're wrapping the NumPy where function, which is really easy to do because we would like to chain it, let's say. Of course, this is not nicely chainable by itself, but just by doing this, everything becomes nicer. Then we have a function that calculates the mean of a column. So we say data frame, take the speed column, take the head. Is it greater than its mean? If it's greater than its mean, because the NumPy where function does this, then replace it with high, not replace it, but write high or write low, otherwise write low. And this is what we get. So just to check, the call mean function, of course, gets us the mean. So we can save everything into a var. This is just the function we used earlier. This is it. And it's the whole series, so the whole column. And we can say that we would like to add this column right here, which is this one, with this name, okay, using the assign function to this data frame. Then we would like to see only the speed level and speed columns, just the first 10 rows, and then show, which is just something to have it nicer right here. Then another very, very nice function, it's value counts, that does this. If you have categorical values, maybe you would like to know how many of them there are by category. This does it by default. You don't have to tell it anything else. Then just to show that you can do pretty weird stuff with already what's in there, let's say that we would like to take the names and make them as a row. There are many ways to do this. One is to just call transpose, then reset index, then transpose again, and that's it, basically. Let's see if that's true. And that is true. We now have numbers as column names, and the first names, the names we had earlier, are now the first row of the data frame. So now what I would like to show you, okay, we have some more times. I'm going pretty fast with this. We will just wrap TensorFlow very fastly. What I did is just add this function in here that takes classes, okay, and does mostly the same thing as for functions, as you can see. But then I can dispatch properly based on the type, on the Python type that I want to. Then I just call this TF function in here, and just to show you that I'm not bluffing, this REPL is empty, and of course it's the one that attached in here. We define a constant array, sorry about that, okay, a constant array called b. Then we define a function which is a matmul, so it's matrix multiplication between a and b, and this is TensorFlow 1.14, so this isn't eager, it's so lazy. So we define a transformation, then we start up a session, then we just call the run function from the session we just created for the C variable, and this is the result. This is TensorFlow running. If you don't believe me, can you see the terminal?
Wow, yeah, that was amazing.
Okay. And this, of course, now it's running on the CPU, but that's just because they're very tiny tensors, and TensorFlow chooses if running things on the CPU or on the GPU. But this works with the GPU as well, because that's it. It's in there, and it's mostly done. If you want to use it, you can do this. So going back to the last slides in here, what I would like to do in the future is to, well, first off, stabilize and complete the API, because right now there's just, I don't know, maybe 40% of the Pandas API, something like that. Improve docs, I'm working on that. The problem is that I'll have to actually fix, well, not fix, really fix, but improve the CLJ doc runtime, because of course the Docker containers don't have Python in there, but I need that to build everything up. So let's see if that's possible and how to do that. Then NumPy submodules, because right now you only have NumPy functions, but there are many submodules like lineage and random. This is pretty clear what it does. This is linear algebra functions, and there's even more functionality in there. Then MicroPanthera, because it's pretty trivial to make all the Panthera functions, well, actually not all of them, but the most important ones, to do what would you expect them to do directly on Clojure sequences or vectors. And so I'd like to think that maybe some of these functions can actually be being taken out from Panthera and then build a micro library with just some vectorized nice functions. Then maybe with some packaging, maybe a line plugin to get everything all at once, so you don't have to deal with Python at all, or mostly. And then maybe it would be nice to present this to the Python community, maybe at the PyCon or at PyData, and see what they think about it. I think it might be nice, but of course now it's early to do this. And this is basically it. So I'd like to give the word back to John.
That was great. That was fantastic. Thank you very much for that. I hope everybody enjoyed it as much as I did. I certainly learned an awful lot there. So are you using this on your current projects then? Is there kind of a lot of things you are using it for or hoping to use it for?
Sorry?
In kind of like, I'm just curious about what kind of projects you're using this on, or what projects you hope to be using this on in the future.
Oh, okay. Actually, as I was saying earlier, I have a lot of coworkers who use Python a lot. I mean, a lot, and it would be really nice to find a way to kind of wrap it in some way, because most of it is Pandas and Numpy. Right. Because 90% of what a data scientist does in these days is Pandas and Numpy, mostly. So, and to actually take it from Clojure and have something that can go one day in production directly on the JVM and running on the JVM and Python, so it's much easier to actually write directly production code.
Okay, that sounds excellent. Yes. Thank you very much. Does anybody else have any questions on the video or the chat? Give it a few moments.
Yes, I would like to ask if that is okay. This is Daniel. So it was just beautiful for both of you. It was just amazing. And what I wonder is, would it be interesting to connect Pandas data frames to some Clojure data type, right? Because this is something we are thinking about, and it relates to the TechML library of doing ML in Clojure. So I wonder if you have any thoughts about it.
Yes, that's something I'd like to do. I mean, it would be really cool if you could choose to use tech data type and or Neanderthal as a backend for something like Pandas. But I don't know if that's possible at this time. Of course, even just getting automatically a data frame from one side to the other, it would be really nice to have. And it's something that I'll probably explore in the future. Right now, I'm really focused on getting things right because there's so much stuff in there. It's really easy to get lost. And also because Pandas has a lot of historical legacy code. So there are many duplicated methods, and they can be either actually duplicate, so they have the same different names but they do the same things, or they have slightly different names but they do the same thing, or they have different names and they do slightly different things but they're mostly the same. I mean, it's just another method with other defaults values. Okay. Did I answer your question?
Yeah, thank you. Yeah. Thanks, Alan.
Any more questions from the audience or from the presenters?
Could you share the Git repository?
Sorry.
Alan, do you have any examples in that Git repository as well that you've shared?
Yeah, actually, the examples I've shown you in the demo, it's much larger in the repo. So if you go in there, there are already a couple of examples. They're Jupyter notebooks. You can look at them on Notebook Viewer or directly on GitHub. And then I actually plan to do many more examples for this. Improve the documentation a lot, because right now there's basically no documentation at all. And of course, if someone wants to contribute anything, examples, I mean, I accept everything at this point, okay?
Excellent stuff. So we've shared the GitHub address in the chat, which is your user account, Panthera, and we'll share that in the show notes as well afterwards. I think DCJ has asked a question about, I think he's trying to summarize what you've done. Seems like you've done a nice job introspecting Python and create Clojure ways of calling it easily. How much of that code is Pandas and Numpy specific?
Almost nothing at all. I mean, the other night I was talking with a friend who I'm kind of trying to take on the Clojure dark side with me. Actually, he likes Clojure, but he just a few months back he went to a new company, and they're a startup. They're building everything very, 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 very fast. He wasn't so confident with Clojure, so he started building everything with Python. Then he does a lot of machine learning stuff. He uses TensorFlow a lot. So we were joking around about what to use, what not. And I joked, well, there's no problem. You can use TensorFlow from Clojure with the GPU. He was saying, no, I almost don't believe that. I have to see the code. I don't understand how you do that. Then I just wrote that function called CLS to deal with classes. I have to find a nicer way to do that automatically, mostly. I was thinking maybe to just take a function that takes an object, a key and arguments. If that's the case, then while you're calling the function, I can inspect the object at runtime, see what methods are in there, match that with the keyword you passed, and then call that function, that method tied to the object, which can be an object or a module, submodule. It's the same thing in Python. For real, they're namespaces. And then you call that function and you don't worry about that anymore. And it came out, I came out with the TensorFlow wrapper, which is bare bones at the moment, but it works. We just saw that, and I think that's really nice to have at some point. And if I find that way to do that, and I release that, you can go right now in the Panthera.numpy namespace, take those functions out, just change the names and the modules, play a bit around with the module names you would like to use, so the types of the function or the classes, and then you get a wrapper for your library for free, basically.
Amazing. That's excellent work. Yeah. And I think Tom's kind of mentioning kind of runtime inspection. Can you also generate types as well?
Are you talking about instances or proper type new classes?
I'm not sure. It's a question in the chat, so I wonder if Tom will.
It's more of a comment based on what Alan was already talking about. It seems like you can put a nice syntactic sugar layer on there, and basically all the work that you're doing too to wrap the API. If using the function call form that you have, which is very data driven, or allow basically have a pre-baked set of namespaces that are just automatically built that have effectively, type-hinted functions. I don't know if that even makes sense, but the idea is you've already done the introspection and you just call them. So you don't have to know anything about, the underlying attributes and all that stuff. It seems like it's very amenable, right, to that, I think.
Yeah, no, actually, at the moment, what is manual is the fact that you have to choose the types. that you want in your wrapper. I mean, you can even say, I don't care, I want everything at some point, and then you use only the things that you want. But then there are also attributes that are not really functions. So if you try to call them, you're getting an error because maybe you're trying to call a constant that happens in Numpy and also in TensorFlow. And then you don't know really how to deal with, because as you saw earlier, there is that built-in function or method keyword, and then the ufunc keyword, which are NumPy types, and you can find them only in NumPy and in nothing else, basically. So that's the only thing that's manual at the moment. I was thinking that maybe just analyzing the names, so removing it under methods and private methods, because private methods in Python are just methods that have an underscore before the name of the method itself. And then try to wrap them in some way, maybe, I don't know if that's possible at runtime. Try to call it. If I get an error, then it's not a callable, it's an attribute. I mean, it can be done probably in some way, but of course that means that the wrapping process will become pretty slow for very large libraries.
Yeah, I think you could do that as a pre-runtime. So basically, you know, as a standalone library, just generate those bindings once, save them. You know, now you have it would need to be tied to the API that you have at the time for that version, but you could, you know, you cache all that stuff and just deploy that as part of your bindings package, if you will. If someone wants to have just the Clojure interface, like like a pre-baked namespace with all the stuff that looks like pandas, but it's just functions that are already built in Clojure. I mean, that'd be the magic side. Really nice. The other question I had, you mentioned an interesting point, Alan, that ties back into what Chris was demonstrating, which is your recommendation is to keep the Python and the Clojure separate. And I have to wonder, as you start to marshal or bridge resources between the two, particularly with the numbers, curious about equality semantics. So if I suck in some numbers from pandas and I shove those into a hash set, and I decide to start trying to use those. Like one of the canonical examples that I have is if you put a float versus a double into a hash set, you can get weirdness and inequality that can throw some non-intuitive results. So I'm curious to know if there's you know, going forward, if there's a way, if that even matters in this case, or if there's a default to automatically marshal stuff. If you're going to shove it into a Clojure or Java backed data structure, that you just kind of have some of that, because I could see that possibly creating some. If there are issues with that, curious some counterintuitive stuff.
Well, actually, I'm answering on the Panthera side of things. Of course, Chris can actually say something more about Libpython-clj. You can always transform types on the Python side of things in whatever you want. There are as types functions, and then you can pass it int32 keyword, and you're getting integers and so much. But this is also one of the reasons I earlier said, try to keep things in Python and in Clojure pretty much separated, and just only maybe at the beginning or at the end of your work, mesh them together in some way.
I think that's a good question, though. I feel like if you want to guarantee that, if you want to sidestep those issues, potentially use the zero copy pathways. And that'll force you to, for instance, have NumPy arrays that are a defined floating point type, and you'll have a whole collection of things, and then you won't get kind of heterogeneous data. But Libpython under the covers will only ever return a double, unless you use the zero copy pathway. So there's no actual like API. Well, there is an API, but I don't use it to say get this thing as a double or get this thing as a float. If it's a floating point number, all I ever call is get this thing as a double, unless you're using zero copy.
Okay.
Great. Do we have any more questions for these two speakers? Any more comments, questions? There's been a lot of... oh, yeah, there we go.
I would love to ask if that is okay. It is
sure.
again. So question to both of you. What would be most helpful to you from the community? What could people do if they wish to help you in what you're doing?
For me, it would probably be, honestly, if you help Panthera get adopted, then that helps me, because just edge cases that filter back, like I tried to do this and it returned a string instead of a double, or who knows what, like issues with the library, especially with Libpython, I really opened a big, I call them a bug manifold. There's a lot of surface area for potential problems. I don't think there are many, and the ones that are there I think are inherent in Python in general, but there's still going to be a lot of possibilities for various libraries and things like that.
Yeah, for me it's mostly the same. If you're using this, and even if you're having success and you're really happy about it, it will be really nice to know how you're using it, what you use the most, what you're missing, and all these kinds of things. Even just this would be really helpful, because as I said earlier, the libraries underneath are huge, and maybe there's something that feels weirder than the other stuff, so it would be much better as the API would, I don't know, even would be much better to thread last instead of thread first. I'm just throwing things around. And then, of course, everything that can help Chris as well on Libpython, it's really nice to have, because if Libpython-clj gets better, then Panthera gets better, and most likely, as Chris was saying, if Panthera gets better, then we have more chances to make Libpython-clj even better. So
one thing that would also be helpful is, one thing I was hoping, and the more I think about it, the more I think this may be the most important thing, is does this change the calculus of a Python programmer in terms of how interesting they think Clojure is? So that is not a question I can answer because I don't know that many Python programmers, but knowing if this changes the weighting of those languages in their mind, that is an interesting one. And obviously I'm hoping for one answer, but knowing it regardless is important.
Yeah, we will see. I think, because maybe there's some killer features that we can have by using Python from Clojure that we haven't realized yet. And if we find them, then we can show them to the Python. I mean, that thing I called with juxt, all those functions on that column. I mean, for me, that's already pretty cool, because I was doing something similar the other day in Python, and either you can chain things up, but of course that's not chain. Juxt is not chaining, is calling them sequentially on the same thing over and over again. And you can do that with regular Python, because map is very limited in what you can do. Actually, the Python map, of course, map function, not the map like the dict. So let's see what happens.
There's an interesting chat. Robert, could you go into a little more detail about CLJS for Python? What do you mean?
Oh, sorry, guys. I was just referring to the fact that it's a prepackaged collection of things that are JavaScript libraries that are meant for use from Clojure script. So I imagine something analogous, Python things that are prepackaged, with the necessary exports and wrapper code, just to make them seamlessly usable from Clojure.
Got it.
Yeah, so with CLJS, you can simply just add a packaged up JavaScript library and just use it as a dependency as you would do in like a normal Clojure script project. You just put it as a dependency right at the top and just require it in, and off you go.
Hi, I'm Kamil. I just wanted to, because Chris mentioned that it would be interesting for a Python programmer to comment on this. So I would consider myself a Python programmer. I did some Clojure. I wrote experimented with the Clojure Emacs.NET API, and I think I like the Clojure way of doing stuff. I think it makes great sense of doing data science in Clojure because of the functional way Clojure handles this, and I would definitely looking forward to trying this out, to trying Panthera, to trying this Numpy and Pandas inside Clojure. So I don't know, just wanted to say. So yeah, great talk. Thanks.
That's
great.
Cool. Thanks.
Yeah, thanks for sharing. Yeah. Yeah, it is. I think both these projects do help kind of bridge that gap between what is seen as two different worlds, even though there is, as we've been mentioned, an awful lot of commonality between the two languages as well, and they both have their own strengths. And I think, yeah, so DCJ in the chat has mentioned that in the near term, like it enables Clojure people to deal with and use and enjoy using a lot of the really good Python libraries that are actually out there. But as we're doing that, then we have much more of an opportunity to evangelize Clojure to the Python programmers that we're working with. And over time, they can kind of see things that they couldn't easily do in their language, and then that would help them kind of have a better appreciation of Clojure itself as well. So I think it does both. It does kind of help in both aspects there.
Yeah, I think so as well. I mean, at this point, most of my work is aimed at Clojure people, and that's why I put the question mark at the end of let's show this to Python people, because I think it's pretty early. We still don't know if this is a good idea. I mean, it might even not be that great of an idea, or maybe it's the best idea ever. So let's see what happens.
Yeah.
That's good.
Chris, sorry, you about to say something?
No, please go ahead.
Yeah, I just got one, not a spoiler, just a counterpoint. So I understand the Clojure to Python bridge and wanting to do that. That makes a lot of sense. If I'm in Python, though, and I want Clojure-like things, why don't I just go use the HY, Highlang, which is effectively, I've played with that in the past, and it's pretty slick, except for it defaults to Python idioms where there's a question, but it tries to be Clojure as well. So I guess if at some point there is going to be a presentation, as Alan was talking about, you probably want to have a way of showing like what does Clojure on the JVM bring you above and beyond what Python is doing, and so what kind of superpowers do you get from that? Rather than, because you have a lateral alternative, just go use high, I think. I'm still somewhat ignorant though, but that would be my layman perspective, just FYI.
So high is kind of like a Lisp, like on the Python runtime. Is that correct?
Yeah, it actually it generates Python bytecode. And so you get it's basically what Clojure does with the to an extent with the JVM, except for you're living in Python, and they have basically native interop with all the Python structure. So you get generators and all that stuff. I believe again, I used it early on, and they're still working on it, but I don't know what the popularity level is. But that's kind of, if I was in Python and I was like, if I had code Python by day and I was looking for a way out, I would probably go to high because it's very, very Clojure-like. A lot of the stuff in there is.
Well, it is, but you're still stuck in the Python runtime, which means that, for instance, a lot of the Clojure idioms are going to have really bad performance. And you don't have access to, JVM libraries or the JVM, as you said in other places, JVM brings a lot to the table. So it depends on why you're interested. If you are just interested in Clojure paradigms and you're doing relatively low code things or not a lot of looping or something, I think high works. But the Python runtime, one thing I was hoping for was that you could interleave Python and Clojure code, because there's times when doing something in Python, especially if you have to do a for loop for some reason, and I know with NumPy you usually don't, but every once in a while you do, you really pay a high price. I mean, you really pay a high price for performance at that point. And with the JVM, you don't pay nearly as high of a price.
Yeah, I think that's the kind of case I'd make is the platform the JVM provides. You can do general purpose programming without paying these prices that you would on, but you can basically get this nice, fairly transparent layer to just touch effectively the efficient C code or whatever that Python's wrapping for you. So you're just using Python as your wrapper layer, right? You're not really using it as your general purpose computation layer.
Right, exactly.
Yeah. So you can okay.
That's exactly what I was thinking. And there may be times when you've got something written in Python that is sucking down a lot of time, and you now have a chance to get back into Clojure or straight JVM or something to deal with just that one piece, and then drop back into Python and do the rest of your work.
Roger.
This is, I wanted to, you know, in the ML talk, Rich said that is there any way that you can, you know, just call the Python C libraries and not use Python? And unfortunately, with the way that people are binding to Python right now, especially with Boost C++, that's not an option. Your only option is to rebuild some portion of the actual Python runtime that then those libraries would interact with. And so this is my absolute best guess or foot forward as to how to solve the library problem in Clojure with ML that Rich kind of was referring to when he was saying, like, how can we get into these Python C libraries? And I know that was an aside, but I wanted to give a shout out because that was actually important. That was a thing that was inspiring me when I was building this.
Yeah, get you out of the C ABI paradigm that you were in before. So now if you can do it with Python, then I think we talked about it in the Zulip too, that opens up the idea of repeating the process with other languages too. So, and plus you get all the Python developers writing effectively bindings to low-level libraries for you. You can just use.
Yeah, in that sense, Python's a better C. It's way less work to use a Python library than it is to use a C library, even with JNA.
Okay. Joel was asking in the chat if anyone has done anything with Clojure and Apache Arrow, and I know that we started to look into it, but Apache Arrow at the moment, it isn't so great. I mean, it's huge, but the nice thing is that the Apache Arrow creator is actually the same guy who created Pandas. So it's really likely that the first language that will have Apache Arrow as a first-class citizen will be Python, and it will probably be on top of Pandas. So if we get this right, we will get it as soon as the Python people will get it as well.
Yeah, that's actually a really good point. And to that point, Alan and I talked briefly because it would take a bit of work. It would take like a month of work or so, but I could put the tech stack on top of Arrow. But what would that actually change? It would take a month of my time, and I don't know that would change enough variables to really make a big difference. But if we just wait and let Pandas go on top of Arrow, then I just think that that's a better route in the long run in a lot of ways, at least initially.
I agree.
Perhaps the most compelling argument that I see is you've bridged, you have a nice high level dynamic way to bridge everything Python has with everything the JVM has to include Clojure, Scala, all that stuff. So maybe, I think there was a talk that Karen gave a while back talking about how Clojure was kind of destined to be the ultimate glue code. So in a sense, you kind of got that above Python even, which sounds interesting to me. That might be the value prospect. And you just keep adding more and more, interop wrappers here and there.
Yeah, I mean, if we think about the whole big data environment stuff that's around these days, it's all Java basically, or JVM, so mostly Scala and Java, and Java is one in that realm. There's no, you can say anything else about it. If you want to do big data stuff, you have to know JVM, at least something that runs on the JVM. So even having a way to deal, we have that way to deal with all the big data environment stuff. We can deal with doing data science on a laptop or even something a bit more than a laptop, it's, I mean, we have a lot of coverage there, and we can, as you were saying, be the glue that takes all that stuff together.
There's also the mention of the CLR too, which could be another entire platform. I didn't even think about that. Chris had mentioned that in chat one time.
Exactly.
Yeah, the CLR has some really amazing characteristics to it. And the one I want to point out that I think is fascinating and unlike anything else is that it can do template expansions at runtime. So for instance, in tech data type, in order to like add 2 floating point readers, I have actually compile time code that generates a type precise way of doing that. And that's important. But in C#, for instance, or if I can bind into the CLR in certain ways, I can basically tell the runtime, hey, if you need to do this with floats, the code kind of looks like this. And the runtime, and that way it's not generated at compile time. So import or requiring data type doesn't take as long, or compiling data type doesn't produce something as big, but you get really well optimized code generation. So the CLR's code generation capabilities are above, to my knowledge, they are soundly above the JVM's code generation facilities.
Yeah, there's some exciting native stuff there too. I think they're going the right direction with like the core RT and then the .NET native. So you can already out of the box do stuff. Plus they have value types if you're interested in that. I mean, there's a lot of functionality there that they're trying to bootstrap onto the JVM with Grail and other stuff, but it's not there yet. Whereas if we were doing stuff on the CLR, in theory, I haven't tried it out. I'm curious now, but like just AOT all your stuff, you want to deliver a binary, you can. I don't know, but and then on top of that, like you're talking about, some of the optimizations on there are fascinating. So I think it's an underused target. Plus I'm an F# fan, so it'd be pretty cool to have some native F# interop playing around.
Oh, +1 on F#. That is an awesome language.
Yeah, that was actually my first functional language before Clojure even. So,
oh, wow. Good choice.
Excellent. Well, I think we've kind of already gone into the kind of community kind of discussion already. So we've got another sort of 8 minutes or so officially left. So if anybody else has any other comments and so on, that'd be great to continue for a little bit longer. No, nothing coming to mind at the moment. Well, everybody's been really kind of positive on the talks and giving lots of really good feedback during the chat. And I'd also like to thank Chris and Alan for the talks. I found them fascinating. I'm still learning an awful lot about data science. So yeah, this has been very, very enlightening session as well.
Thanks for hosting, John. You have a very nice, like a newscaster voice. So, yeah, you could be the spokesman for scientific Clojure. Yeah, it's good. Excellent job.
I found that as well.
Thank you. I try my best. Yes, I try not to talk too much. When I know what I'm talking about, I can really talk for hours. So you're safe yet, because I'm still got a lot to learn. But yeah, I just found I missed the very first video of this meeting, but I've watched all the other ones and really enjoyed it, and it's just been it's been fascinating what you can do. I mean, I think one of the things that I like about what we've covered today is that it's encouraging the community, the Clojure community, to use what's already there in the Python world, which therefore means we're not threatening the Python world. We're not coming in and trying to rewrite everything. We're almost like coming in and celebrating what they've already done by using it and making the most out of it as well. So I think that's a really kind of a really positive story of what we've been doing today as well.
Yeah, if we can reduce the us versus them discussion,
yeah,
I think that's smart, because really Python and Clojure share a lot of similarities. If you just look at a broad spectrum of all the language we know of in computer science, Python and Clojure really aren't very different.
Yeah, and then we can just talk about runtimes, because people, unless they're building the runtimes, they are less protective about that. They're more protective about the languages that they express themselves in, and the runtimes, they're probably more flexible in what they're doing as well. And I think earlier in the chat we also mentioned some other options about running Python. You could even use Graal VM, which again potentially taps into the power and kind of all the goodness that's been pumped into the Java virtual machine over the last 20 odd years. And so Graal VM is kind of like, it looks like it's kind of very promising. It's certainly something Oracle are investing a lot in, and could be like in the future as like some platform that brings all these languages together, and encourages and keeps on encouraging the big diversity we've had in languages as well. I still remember, and I'm showing my age here, is when I was like developing, when I started developing, you either did, well, I think it was C++, and then it was you either moved on to either Java or C#, and there wasn't really anything else. I mean, unless you're in academia, you might be doing some Python, but it was that. But now, I mean, there are hundreds of languages out there, and you can express yourself in many different ways. Yeah, and I think the opportunity is we can reach out to people in the Python community and say, well, this is what we're doing with your stuff, and this is how we're enjoying it and making some valuable applications out of it. And hopefully they come and look in more depth about what we're doing as well.
Just an addendum in terms of the us versus them and taking that barrier down. Another way that we might be able to add a value prospect towards our utilization of, or folks' utilization of Python, is that if you're going to be, Chris mentioned garbage collection issues and other things like that, but there might be additional things that we might end up leveraging some of their code paths in ways that they aren't naturally. And then that might expose some edge cases that we can actually help at least submit some forensics on for improving their product and patching it up and hardening it. So it might be that there's some value added in terms of contributing back to their ecosystem on the quality assurance side if we run into some of those cases.
Yes, very good point. Thanks, Tom. And any other questions? Any other comments?
I don't know. Has anybody worked around with the early access release of the Panama project? I don't know if anybody's heard of that, but that's kind of like the new JNA, next generation JNA wrapper for CD APIs.
No, I haven't. It's not so easy for us to bump JVM versions. I've got really in trouble with my partners for bumping a version on a project without really consulting everybody because a lot of our tooling broke. But absolutely, JNA is sufficient, but it would be better for that level of integration to be in the actual virtual machine like it is in the common language runtime. And I imagine if you get down to splitting hairs, probably if you pressed it could find performance issues. But again, use zero copy pathways. Convert your data to dense heavy buffers and zero copy the whole thing, and then you won't have performance issues. JNA is bad when you have chatty interfaces, but you can never make a chatty interface fast. It doesn't matter what you're using.
Interesting. There's so much out there to go and have a look at. Yeah, so Project Panama on the OpenJDK, that looks, yeah, something else that potentially interesting, but as Chris says, there's possibly better ways to actually deal with that. Okay, we're about up to time. So again, we can hang on later on, but we'll close the recording, I believe, at 2 hours. And I think Daniel is going to keep the chat open if we want to keep on the conversation. But again, thank you very much, Chris and Lan, for the excellent talks, and I wish you well with all the projects you're working on, and I hope everybody does kind of get involved and continue and give you lots of great feedback. Thank you very much. Thank you. Virtual applause. Yes.
Thank you, everybody.
Thanks, everyone.
Thank you.